All right, welcome. We're going to do day 1, which is 11.1 systems of 2 linear equations and 2 unknowns. This should be pretty familiar to you from Algebra 1 and Algebra 2. So here are some examples of linear equations that either intersect in one location, no locations, or infinitely many locations. So we call this first system consistent if it has one intersection point. When 2 lines are parallel, then they have no intersection points. So we call that inconsistent. And then if we have one line on top of the other line, like with this one, they intersect in an infinite number of locations. So we call that consistent. So that's if you're looking at a graph. And then if you are trying to solve algebraically, you could also use substitution or the addition-subtraction method, which we often will call the elimination method. So supply and demand functions have an equilibrium point at the solution to the system of the supply and demand equations. So the equilibrium point is also known as the intersection point. And the intersection point, like the location of the coordinates, is the price, comma, the quantity. So P, comma, Q. All right, so we're going to do number 1. It says, is 14, negative 2 a solution to this system? So I would plug in 14 for x and y, make that negative 2. So we've got 14 plus negative 2. Does that actually equal 12? That is true, so 12 does equal 12. And then if we do 14 minus negative 2, does that equal 4? That definitely does not equal 4. That's 16 equals 4, so that is false. So final answer to this one is no, it is not a solution. All right, the next one says solve by substitution. So please make sure you use the method that they request. So with solving by substitution, we have to get either x or y by itself. So you need to decide which is going to be the easiest variable to solve for. Probably the one with the coefficient that's closest to 1. So I would suggest solving for y in the first equation. So if we do that, we've got 4x plus 2y equals 3. And if I subtract 4x on both sides, I have 2y equals negative 4x plus 3. And then if I divide everything by 2, I have y equals negative 2x plus 3 halves. So I'm going to take this expression negative 2x plus 3 over 2 and put that in for the y in the second equation. All right, so we have 10x plus 4 times something equals 1. And I'm going to plug in negative 2x plus 3 over 2. So if I distribute my 4, I get negative 8x, and then I get 12 over 2, which is 6. So combining like terms and subtracting 6 on both sides, I have 2x equals negative 5, and x equals negative 5 over 2. The biggest mistake that people will make is typically just stopping here and not solving the entire system. You've got a value for x, but you also need a value for y. So at this point, you need to plug in negative 5 halves in for x, and I would go back to this y equals part. So negative 2 times negative 5 over 2 plus 3 halves. That's going to give us 10 over 2, which is 5, plus 3 halves. So that would be 10 halves plus 3 halves, and that's 13 halves. And that's equal to y. So final answer should be written as an ordered pair. And so your final answer would be negative 5 over 2, comma, 13 over 2. All right, the next one says solve by addition, which is your elimination method. So your goal here is to try to eliminate either the x's or the y's. And in order to eliminate them, they need to be the same coefficient, but one needs to be positive and one of them needs to be negative. So I think the easier one would be to try to eliminate the y's. And to do that, I would get the bottom equation to say negative 6y. So if I multiply through by 2, you can multiply by whatever you want. That gives me 4x minus 6y equals negative 6. And then the top equation did not change. 5x plus 6y equals 4. And now I just need to add together, and you'll notice the y's cancel. So we have 9x equals negative 2, and x equals negative 2 over 9. All right, but again, don't stop here because you need to find the value of y. So pick any of your 4 equations. Maybe pick the ones with like the smallest coefficients. So I would probably do the 2x minus 3y. I could plug it into this equation or this equation as well, but we're going to go with the one with the lowest coefficients. So 2 times negative 2/9 minus 3y equals negative 3. And then that multiplies to give me negative 4/9 minus 3y equals negative 3. And if I add 4/9 to both sides, I get negative 3y equals, and I'm going to change this to say negative 27 over 9 plus 4 over 9. So that gives me negative 23 over 9. So my last step is to divide everything by negative 3. So that gives me y equals negative 23 over 9 times negative 1/3, which is 23 over 27. So my final answer should be an ordered pair. So negative 2/9, comma 23 over 27. And just so you know, regarding the quiz for this chapter, this would be on the no calculator part. So even though there's some fractions in there, you should be able to do it without a calculator. All right, moving on to problem number 4. It says, find a parabola that goes through 0, 4, and 2, 14 in the form of y equals x squared plus bx plus c. So there's no ax squared, so there's just a 1 in front of the x squared. So we know that these are x and y. And I would just substitute in x and y into the equation, and then you'll end up with something that you can solve a system to find the remaining variables. So in the y equals x squared plus bx plus c, I'm going to change y to be 4. And then x squared is 0 squared plus b times 0 plus c. And conveniently for this one, the zeros cancel out, so you're just left with 4 equals c. Then we're going to go to the equation again, and this time we're going to substitute in 2 and 14. So 2 squared plus b times 2 plus c, and that should be equal to 14. So if we simplify that a little bit, we get 14 equals 4 plus 2b plus c. But now I know that c is equal to 4, so I can substitute that. So I have 14 equals 4 plus 2b plus 4. And then if I combine my like terms, I have 8, but if I subtract 8 on both sides, I get 6 equals 2b. So b is equal to 3. All right, so my final answer is, what is the equation of the parabola? So that would be y equals x squared plus 3x plus 4. All right, in number 5, this is one that relates supply and demand to solving systems, but you would be able to use a calculator on this one just because the numbers are pretty large. It says that the supply equation is Q equals 15P, and then the demand equation is Q equals 12,493 minus 50P. So if the price is set at $50, will there be a shortage or a surplus? And then what if the price is tripled? So let's look at the supply equation, which is Q equals 15P. And the price is set at $50, so P is price. And if I do Q equals 15 times 50, I get that Q is equal to 750. All right, then I'm going to use the demand equation. And I know that that is Q equals 12,493 minus 50 times P. But we know that P is equal to 50 because that's our price. So Q equals 12,493 minus 50 times 50. And if you do that, you can plug that in your calculator. You'll get 9,993. All right, so you have in your supply 750 items. But the demand from the consumer is that they need 9,993 items. So there's definitely going to be a shortage because we are not going to have enough supply to meet our demand. So if we went with a tripled amount, that would be P equals 150, and we could try the supply and demand equations with that. So for the supply equation, we would have Q equals 15 times 150, and that's going to give us 2,250. So we need that quantity of items. And then for the demand equation, we have Q equals 12,493 minus 50 times 150. And if I do that in my calculator, I'm going to get Q equals 4,993. So is there going to be a shortage or a surplus? Still, there will be a shortage because the supply is less than the demand. All right, in part B, it says, show if the price is $200, there will be a surplus. How many items will be left unsold? All right, so let's just substitute in our equations. The number 200, so Q equals 15 times 200, and that gives us a quantity of 3,000. And then the demand is Q equals 12,493 minus 50 times 200. And if we do that, we're going to get 2,493 as our quantity. And it says, show that if the price is 200, there will be a surplus. And we know there's a surplus because the supply is larger than the demand. So if we do 3,000 minus 2,493, we get 507 extra or unsold items. Then in part C, it says find the equilibrium point for these supply and demand functions. So it's got to be somewhere in between the 150 price and the $200 price. Basically, we want to solve this system of equations. So Q equals 15P and Q equals 12,493 minus 50P. All right, so I think that substitution is going to be your easiest method here. So I've got Q equals 15P. I can replace that in for Q in the other equation. So it's 15P equals 12,493 minus 50P. And if I add 50 to both sides, I get 65P equals 12,493. So last step would be to divide those two numbers. So 12,493 divided by 65. All right, so that gives us 192.2, which this is a price. So we're going to change this to 0.20. And to find the equilibrium point, I would need to know the price and the quantity. So I'm going to solve for Q by doing 15 times 192.2. And that's going to give me my quantity, which is 2,883. So equilibrium point should be 192.20, comma, 2883. Number 6 is also going to be a with calculator problem. So another real-world scenario to use a system of equations. So it says how many cubic centimeters of a 10% acid solution and a 35% acid solution are needed to get 200 cubic centimeters of a 25% acid solution. So one has too much acid, one has too little acid. We mix them together in a certain quantity. We should be able to get the appropriate amount of acid. So 25% is our goal. All right, so the way that we'll set this up is we're going to basically make like a little grid. And our first thing is that we need to represent the cubic centimeters. And then the second thing we need to represent is the percent of acid. we are told that there is some 10% acid solution. And in that, we don't know how many cubic centimeters we're going to use, so that would be an unknown. But we do know that the percentage of acid in that particular quantity would be 0.10x, right? 10% of some unknown amount is 0.10x. So we will call this leftmost column the percent. The next thing that we're trying to look at is the 35% acid solution. So there's going to be 35% of something. That something is going to be some unknown amount or quantity of liquid, which is y, since we already use x. And if we multiply those together, we get 0.35y. All right, so for our final row, we know that we're going to use 200 cubic centimeters total of liquid. And there's going to be 25% acid in there. So just like we did before, we're going to do 25% times 200. If you multiply that out, you get 50. And then these columns will help us set up our equations, our two variables, two equations system. So we've got x plus y equals 200, and we have 0.10x plus 0.35y equals 50. All right, so if we had started right here, you would know what to do right away, right? You would solve by either substitution or elimination, but we just had to create our equations first. So I think it really helps if you create this chart. It'll help you stay organized with all the numbers and values. But at this point, we can do whatever we want to solve. So I would say if we multiply this top equation by some amount to either cancel out the x's or the y's, that would probably be our best bet. So I'm going to go with multiplying by negative 0.10, just so that we can get something to cancel out to the positive 0.10x. So we're going to do negative 0.10x, negative 0.10y, and 200 times negative 0.10 is going to give us negative 20. Positive 0.10x and negative 0.10x add up to 0. If we add together the y column, I get 0.25y equals 30. And then final thing to do is divide by 0.25. So now we're going to get that y is equal to 120. So it's 120 cubic centimeters of 35% acid. And then we need to find the other half of the answer. So we should plug in the 120 into one of our equations, probably the top one. So x plus 120 is equal to 200, which means that x is equal to 80. So then write a little sentence about that as well. So 80 represents 80 cubic centimeters of 10% acid. The final question, it says solve the following system. So we have a system of equations that has two unknowns, x's and y's, but it's weird because it says natural log. So I think using like a u substitution might make the most sense for this. So we see that this is natural log of x, natural log of x. Let's just let u equal natural log of x. And then similarly, we've got a natural log y and natural log y. So we've got v equals natural log y. So now we're going to solve our system by substituting. So we get 3u plus v equals 3, and 4u minus 6v equals negative 7. All right, so now we're going to multiply the top equation by 6, because that'll get opposites for the v variable. So we'll have 18u plus 6v equals 18. And then the bottom equation we're not changing, 4u minus 6v equals negative 7. And then we just need to add. So if we add the two bottom equations together, we get 22u. The v's cancel because 6v and negative 6v are opposites. And then that equals 11. And if I divide both sides by 22, I get 1/2. And then if I substitute into 3u plus v is equal to 3, I have 3/2 plus v is equal to 3. So 3 minus 3/2 is also 3/2. So 3 minus 1/2 is going to give me 1/2. All right, but it says to solve the following system, and the original equation had x's and y's in it, not u's and v's, so that means we need to go back and re-substitute in the natural log of x is equal to u. So natural log of x is equal to 1/2, which means that you need to change to exponent form, and as a reminder, natural log has a base of e, so e to the 1/2 is equal to x. Then I need to do the same thing with the y's, so natural log of y is equal to v, which means that natural log of y is equal to 3/2, exponential form, so e to the 3/2 is equal to y. And since it says solve the system, we're going to put our final answer in as an ordered pair. So e to the 1/2, comma, e to the 3/2. And that should be your final answer.